Hi guys, I want us to do this analytical problem together. So it says in the diagram we have points P, A, R and M are the vertices of a parallelogram PARM. So P, A, R, M form a parallelogram, and then they go on further to say that PMT is a straight line such that M is the midpoint of PT. So PMT here is a straight line and M is the midpoint of PMT. Then they give us another coordinate and they say that this point is such that PT is perpendicular to RT. So PT and RT are perpendicular at point T. And the first question says determine the length of PT, leave your answer in insert form. So they want us to find the length of PT. So we need to apply the distance formula and we need to use the coordinates of P and T. So the distance formula for PT, it can be written as PT should be equal to the square root of P minus XT squared plus YP minus YT squared. So I've just placed XP and YP in the place of 2 and 9 and XT and YT in the place of 10 and minus 3 to make substitution easier. So this here is equals to the square root of XP is 2 minus 10 squared plus YP. YP is 9 minus YT is negative 3 squared. So this here is equals to the square root of minus 8 squared plus 12 squared. This is equals to the square root of 64 plus 144, which is equals to 208, the square root of 208 units. So the next question wants us to find the gradient of PT. So there we can apply the gradient formula. So notation is important. Small letter m, gradient of PT is equals to change in y, which is yt minus yp over xt minus xp. So we can just substitute. Yt is minus 3 minus 9 all over xt is 10 minus 2. So this is equals to minus 12 over 8, which is equals to negative 3 over 2. So the next question wants us to find the gradient of AR. AR is given as this line, and we notice that AR is parallel to PT. So if lines are parallel, they share the same gradient. So we can say that MAR is equals to MPT, which is equals to negative 3 over 2. And this is because AR is parallel to PT. The next question wants us to find the coordinates of M. So as we've said earlier on, M is the midpoint of the line PMT. So we can apply the midpoint formula. So M is equals to XP plus XT over 2 YP plus YT over 2. So we can just substitute. XP is 2 plus 10 over 2 and YP is 9 plus negative 3 over 2. So this is equals to 12 over 2 and 9 minus 3 is 6 over 2. So this is equals to 6 and 3. So the next question says determine the equation of PM in the form of y is equals to mx plus c. So let's identify the line PM. So PM is this line here. So we need to find the equation of PM. But notice that P, M, and T are collinear, meaning there are 3 points that share the same line. So it means that PM and PT will share the same gradient. We've got the gradient of PT. So the gradient of PT, we've established it to be negative 3 over 2. So therefore, we can say that the gradient of PM is equals to the gradient of PT, which is equals to negative 3 over 2. And the reason is PM and T are collinear, and this word is particularly important. If 3 points lie on the same line, we say they are collinear and they share the same gradient, right? So we've already found the gradient of PM to be negative 3 over 2, but they asked us to find the equation. So let's start by writing the standard form of the equation. Y is equals to mx plus c. We can substitute the gradient. So y is equals to minus 3 over 2c, and we can substitute the coordinates of any of these 3 points to find the c value. So I'm going to use p. So when the output is 9, negative 3 over 2, the input should be 2 plus c. So 2 and 2 cancel out. So therefore 9 should be equals to negative 3 plus c, and this implies that c should be equals to positive 12. So therefore y should be equals to negative 3 over 2x plus 12. So the next question says show that n is equals to minus 5, right? So they want us to find this, the value of n here, the x coordinate of r, right? But you will recall that PT and RT are perpendicular lines, and we found the gradient of PT to be negative 3 over 2. We've established this. So it's possible to find the gradient of RT by taking advantage of the fact that PT and RT are perpendicular, and if that's the case, we know that the product of their gradients is equals to negative 1. So using this fact, we are able to find the gradient of RT. Once we can find the gradient of RT, then it will become possible to find n. So we can substitute MPT, as we've seen, is negative 3 over 2 times MRT is equals to negative 1. So we can multiply throughout by 2 over 3, or negative 2 over 3. So this and that cancel, that and that cancel. So it means that MRT should equals to 2 over 3. So now that we found the gradient, we can make a connection between the gradient and n using the gradient formula. So we can say that MRT is equals to change in y, which is yt minus yr, over change in x, which is xt minus xr, and we have the gradient of RT to be 2 over 3, so we can substitute it. 2 over 3 is equals to yt negative 3 minus yr negative 13 all over xt is 10 minus xr is n. So this is 2 over 3 is equals to negative 3 plus 13 is positive 10, so it's 10 all over 10 minus n. So now we can cross multiply. So this here is 30 is equals to 20 minus 2n, and if you take 20 over, the sign changes. So now we've got 10 is equals to negative 2n, therefore n should be equals to negative 5. So this here has been shown. So I want us to just remember this important formula. Products of the gradients of perpendicular lines is equals to negative 1. And the last question says calculate the area of triangle RMT. So RMT is this triangle. They want us to calculate the area. So we know the area of a triangle. Area of a triangle is equals to half the base times the perpendicular height. So for the given triangle, we can already just donate the names. So line RT is the base and MT is the perpendicular height. So it's easy to find the perpendicular height because we found the distance of PT to be square root of 208 earlier on, and we know M is the midpoint, so this should be half the distance. So we can already substitute. The perpendicular height is equals to square root of 208 divided by 2 units. So now we just need to find the distance of the base. The base is RT. So we can use the distance formula there. So we can just substitute xt 10 minus negative 5 squared plus yt. Yt is minus 3 minus yr negative 13 squared. So this is the same as the square root of 15 squared plus negative 3 plus 13 is 10 squared. So this is equals to 15 squared is 225, 225 plus 100. So this is equals to square root of 325 units. So now that we have all the necessary parameters, we have the base, we have the perpendicular height, now we can substitute it into the formula to find the area. So this is equals to half the base is square root of 325 times square root of 208 over 2. So I just reduced this and I wrote it in decimal form, and this is equals to approximately equals to 64.9963, which can be approximated to 65 square units. Thanks for watching. See you in the next one.